Good afternoon. My name is Bakir Malik. I'm the Director for Sales Engineering for Niagara Networks. So in today's environment, we all talk about, we evolve so much. We talk about network performance monitoring systems, application performance monitoring systems, network detection systems, and all of that fancy stuff, because our networks have evolved so much and we need to monitor and run the application performances and see what not and all that. But the main question arises, is our network ready to handle all of that system? We have data centers and networks and interconnections and campus systems running, and then from the initial stages of just having one or two solutions to some kind of basic performance monitoring, all that we have evolved to where our departments are even divided into network operations departments, security operations departments, risk assurance departments and all that. And all of those solutions sit on our network. But the question arises, is our network ready to handle all of that performance, all of that demand from these different solutions that sit on the network traffic? And that's what we are here to discuss today, and how to evolve that network to meet the demands of today's security solutions or monitoring solutions or the performance solutions that sit on our network. Okay? So what I'm going to do, first of all, a little bit about the company, Niagara Networks. We are a company based out in Fremont, California. We are a network visibility company, which I will explain in a couple of minutes what that means in overall architecture and the system and infrastructure of today's environment. We are a hardware and software company, meaning our hardware and software both are produced in-house in our own systems. And we have some global customer bases all over the world. We have main offices in the United States. Then we have Western Europe and APAC and other regions as well. Okay? Now, what we look here is the problem that we face in today's environment when we look at different solutions. So if I look at the right side of this slide, I see a typical network operations or security operations systems. Anyone here who is a network engineer or a security engineer or some kind of partner would recognize these systems. We have network performance systems running. We have some intrusion detection systems running. You have some detection systems running and all that stuff. And on the right-hand side, you see a typical infrastructure, right? A typical campus infrastructure. And the problem here is that all of these systems that we run to make our networks efficient and do better monitoring and security, they need to be connected to this network, because the actual working of these systems run on a basic thing, that's packet data. They all require a copy of the traffic to be forwarded to them in order for them to run. Take it, any application system, any performance system, and all that. Now, traditionally, what do we used to do? If we are a little bit technical, we do something called as span or mirror sessions, right? If it's a Cisco switch, or if it's a Juniper switch, or take any switch, if I want to send a copy of my traffic to any of these solutions just to monitor my network or some kind of detection, I need to forward the copy of this network traffic to these solutions. Now, traditionally, what we do span mirror sessions, which was working fine until a decade. We had one or two solutions, one IDS here, one maybe some monitoring solution here, 1 gig of links coming up in. So it was fine. We just take a port from our switch, core switch or whatever, hook a cable to it, make the copy of the traffic and forward it. But as we evolved, the security got more complex, the monitoring got more complex, the performance, became so valuable that we had to maintain SLAs and whatnot to keep the network up and running. And that became a problem. The slide itself shows that I'm a problem. Imagine you just have 3 or 4 solutions that are dependent on your infrastructure network, and you have to send the traffic to all of those solutions. This is what it looks like on a minimal level. If I'm just hooking up to some switches, just to gain some visibility on the network. And as I grow more and more, I need to repeat the same exercise. Now, what is the problem here, apart from this slide looking so junky? Number one problem is the performance of your own infrastructure. Let's say your switches, Cisco, Juniper, whatever, it's built to do what? Switching, right? To send traffic from port 1 to port 2. That's its main job. Now, it's a feature in these switches to make a copy of the traffic and forward it outside, okay? But the problem arises as soon as this switch, any of the switch hits some level of percentage of performance, let's say 40, 50, 60%, it's going to stop doing mirroring and switching because that's not its main job. Okay, it's going to focus on switching. Now we have a problem here. All of our systems that are dependent on this packet data are blank. They are not receiving anything because our switches have gone up, and which is a very predominant problem in today's network because we are not running 1 gig and 10 gig links only. We are running 40 gig, 100 gig. We are looking into 400, 800 gig links in testing in some environments. Because our bandwidth utilization and our applications have gone so heavy that we require these bigger pipes. And in order to copy that traffic and send it out to these devices has become an even bigger problem. Okay? So our performance rapidly gets decreased. Okay? We talk about scalability these days, that our network should be scalable. I should be scalable in a very easy manner. If I want to do something with my network, it should be effortless. By looking at this slide itself, it looks like it's not scalable at all like that. The scalability becomes a huge problem. If I have to just take another solution to monitor my network in any other way, I have to rerun all of these exercises because these solutions are not talking to each other. They're not going to share data. You have to take it from the network, and all of this exercise had to run again. So your operational cost goes up. Your engineering team needs to rerun all of these things, locate a port in a switch where the performance is not that high, I will make that port available, run the cabling system and all of that stuff, and keep on doing it again and again and again. And then the total cost of ownership is high, not on that part. So let's say I give a simple example. Let's say you want to buy a network detection response system, in order for your security team. So you have to forward a network data. So they usually say, okay, how much of the network traffic am I ingesting in? Is it 1 gig, 2 gig, 3 gig, 4 gig? Based on that, I make my calculations. With the spanning system, you're basically taking all of that traffic and forwarding it to it. And you're telling him, you do the cleaning, you decide what is important and what's not important, right? So most of the time what happens, it does the cleaning, it drops the traffic it doesn't require, and then takes the important part only. But it's charging on everything else. So your total cost of ownership is high. Where you just required 1 gig of 2 gig of traffic to be monitored or optimized, you're paying for 5 gig, but actually utilizing for 1 gig or 2 gig. Because there is no pre-filtration or looking at the traffic of what needs to be done and what is important and what's not. Okay? So all of this combined is where we come in and solve the problem. Okay? Now, how do we solve this problem of having a better visibility and more scalable network in place? Okay? So I look at the same structure, same systems, same typical infrastructure campus network. Now, the first thing we do is we eliminate the need to utilize your switches for copying and mirroring of traffic, because that's the main issue here. So how do we overcome that problem? We use something called as tap devices, which are dedicated hardware or software devices that sit on your link, in order to capture the traffic. Their only job is to capture the traffic that's going between the links. Okay? So the first problem of utilizing your switches for mirroring and spanning is gone. No need to look at your switch performance. No need to look at the ports that you need to utilize. Nothing at all. So you deploy these taps at all critical junctures, okay? And you also deploy them in your virtual infrastructure. Now, there's a concept of north-south traffic and east-west traffic. Some may or may not be familiar with this terminology. North-south traffic is basically my user going to the internet. That's north-south traffic. Now, the east-west traffic comes into part, especially in financial institutions and all that stuff, where I have virtualization in place. The traffic going between the servers, all right? There is no way of spanning it over there, so I have no visibility what's going on in my virtualized environment. And this is where we come in with something called as virtual tapping solutions, where we look at the traffic that goes between these virtual systems in place, okay? Once this infrastructure is laid into place, then what we do is we don't just take all of this and forward it as it is. Then we are still inefficient. We are still sending all the traffic to these systems, and we're not making things better or life better. What we do is we send it to something called as an aggregation point, which is called a network packet broker. Now, this becomes a common aggregation/distribution point for all the traffic that's being captured. Okay? We collect all the traffic, we send it to the network packet broker, and from here, we connect your solutions. no matter how many they are, based on different speeds, whatever, and all that stuff. Now, it's not, like I said, it's not just forwarding the traffic. It's an intelligent system. Here we decide what traffic should go to which solution in order to make its performance better, in order to make it efficient, and in order to have more control over what you want to do with your traffic on the network. Okay? So this is where we bring in the, we aggregate all the traffic. So let's say I have 10, 15 different links coming into my packet broker, and I can all send that traffic over a single link over to the system, which it doesn't require to be 2, 3, 4 sensors just to accommodate the links. So we make this intelligent decision on the packet broker, and then we forward the traffic to the right tool. Now this fixes another problem, which is currently, let's say, in the system. Now, a lot of upgrades are happening in the infrastructure, right? Some are upgrading to 40 gigs, some are upgrading to 25 gigs, some are upgrading to 100 gig, okay? If I remove this aggregation point from the picture for just conversation purposes, if I have to upgrade this environment, the infrastructure, I need to upgrade both the sides, right? I need to upgrade my infrastructure, which is on the left side, and I need to upgrade my systems on the right side. Otherwise, it would be a mismatch. Let's say I upgrade my infrastructure to 100 gig, but my system is still running on 1 gig, 10 gig, their systems. I can't send the traffic to them because they don't have the capacity to take it. So either I upgrade both the sides, my solution side and the infrastructure side, or I stop. Now, when we build this visibility layer in place, this problem is solved because it becomes the broker. That's why the name packet broker in between. It becomes a broker. So if you upgrade your infrastructure to some 100 gig or whatever core switches and all that, but you still have legacy systems that you want to send the traffic to for monitoring and all that purposes, we take the traffic at that 100 gig link, and then we send it to each and every solution depending on what speed they are still running on without dropping the packet. And that's where the added advantage comes into place. It becomes that gap. You can do upgrades systematically, one by one. You don't need to look at all the systems in one place, okay? And then the total cost of ownership is, it all boils down to money, we say at the end. So the total cost of ownership comes down. Why? Because you have a fixed infrastructure in place, which is an overlaying architecture, visibility architecture. Your systems are running. So if you have tomorrow some other system, which solution that your company decides to buy for some security or operation systems or performance systems, all you have to do is take that system, plug it in the packet broker, and you're up and running in 5 minutes because it's the common aggregation point and the distribution point. So the time to implementation is massively reduced. There's always a hustle between network team and the security team that I have a solution I need to implement. So the network team says, I need to see where I have availability. You need to stop this and that. So even the POCs or the implementations takes time just because we have to figure out how to implement it into a network. But here, all you do is you take a cable, you plug it in, and you send the traffic to it. And all the system is out of band, meaning it does not disturb what is going on between the network, okay? Now, the main question here arises is, if I know in some minds there will be, okay, my tapping devices are sitting in line of the traffic. What happens if that tap device goes down? Am I going to have a downtime? That's the main question because my tapping devices are sitting in line of your traffic because they are capturing the traffic. If they go down, what's going to happen? It's a critical system, financial system, service provider, whatnot. Now, these devices are hardware devices. If they go down, they have something called as internal fail to wire or bypass in the system itself. If they go down, the traffic will flow through the network without going down at all. The packet broker is out of band. So even if it goes down, your network is not affected at all. Only the taps sit in line. That's why there's a fail to wire in the tapping system itself. It's a hardware system that is built inside with zero downtime. For the SLAs and all those purposes, okay? Now, moving forward, this is the traditional infrastructure. Now, we have also involved our infrastructure. We are talking about cloud environments or virtual private clouds or, all that stuff to expand hybrid systems. Now, the visibility has also evolved from those systems. So we have the traditional infrastructure, which we use the physical taps and all that stuff. And then we also move the visibility part to the cloud system. because we also need to monitor and see what's going on in our cloud environment, be it public cloud, private cloud, virtualization, VMware, OpenStack, whatever is running in the environment. There's a haywire of systems of virtualization running in the environment. So we take both the sides of the coin. We look at the physical infrastructure with physical systems, and we look at the virtual infrastructure. We capture the traffic from both the sides. We feed it to the common distribution point, which is this aggregation / whatever you have. And from here, we run the intelligence for the system. Now, there are multiple layers of intelligence we can run on the system. One is the basic system. We do some basic filtering, some load balancing, and all that stuff. Then we run into some advanced functionality. Some use cases I can give right off the bat. So let's say I'm tapping at multiple places, right? I'm tapping physical, virtual, all of those links. There's a high chance I can capture the same traffic at multiple points, same user traffic, and forward it to my packet broker and then forward to my systems. That means I'm feeding it copies of the same traffic, duplicate traffic. Now that's also inefficient. What to do? So in that case, what we do is we remove the duplicate packets by a feature called deduplication and only send the original packet. So it does not burden the end system that is receiving that traffic. Okay? Another use case of those features, applications, especially in, let's say, service provider environments or something. Or in financial systems. So I'm capturing the traffic, and there is a lot of applications like social media applications, YouTube applications, and all of that stuff that the users are using. But my systems that are monitoring my network for whatever reasons, they don't require that infrastructure, that traffic, that application traffic, YouTube traffic, because it's not interesting to them. So we filter out those applications and only send the interesting traffic to the systems, really making efficient and increasing their performance in the end. So all of that goes through this visibility layer. And once we run all those checks and everything, then we forward this to whatever solutions are connected to us. So we really become the step 0 into the step 1 of your building a network operations center and a security operations center, monitoring, application monitoring, network performance monitoring, and all that stuff. Okay? So typically what happens if anybody wants to look into a solution, end solution, okay, somebody wants an NPM, network performance monitoring solution, or a network detection system for the security reasons. They go ahead and straight away, let's say, go to that vendor. They call them, hey, I need an NPM solution or a detection solution. The first question they ask back is, okay, how are you going to forward me the network traffic? Because my bread and butter is a copy of the traffic. I can do spans, but how many spans can you do? And can you guarantee me that the traffic from the spans will come to me all the time? Will not drop anything? I will give you one sensor that is 5 gig. It only has 2 ports in it, or 3 ports max of 10 gig. How many span links will you send me? I will send you 5. That means I need 2 sensors. Even though your traffic is only 5 gig, just to accommodate those links, I need 2 sensors just to take the links. Okay, and that's additional cost. You didn't need that, but just to accommodate the links, you just have to buy 2 sensors in that case. Okay? So that's where we come in and make the whole system efficient. We become that building block on top of which it becomes easier to build all of those operations and performance and whatever solutions you have in place. So that's how the efficiency comes into play with this overarching visibility. Does it change the layer 2 architecture of the network? No, it does not, because this is all layer 1 system. It does not change the IP scheming. It does not change the MAC address picking, nothing. Does it create any downtime in the network? In the deployment time, especially taps, yes, because we had to connect the cables only. But once it's established, does it create any downtime? No, it does not, because it has failed to wire and it's out of band. Okay? Does it create delay in sending the traffic? No, it does not, because the packet broker works at line rate. If it's taking traffic at 100 gig, it's going to forward it at 100 gig because of the chipsets and the ASICs that are built inside it. Does it have the capacity to scale? So right now I have 5 solutions. Let's say tomorrow I have 20 solutions. Do I need to buy another layer? No, because of the density that is provided. The idea is to be scalable. So I have 20, 30, 40 ports in this visibility layer. I just keep on adding and adding and adding without causing any problem. Okay? What if my traffic rate increases? No problem. This system can scale up to 2 terabytes of traffic because it's a hardware-driven system. So all of those benefits and functionalities come with this, a pre-block of all the big talks and all the big solutions and the monitoring and all that maturity model We talk about security maturity model or the performance maturity model in the network to build the system, but it all rests on a simple agenda of, is our network ready to be built for that maturity level? Or am I just going through that system and then all of a sudden I need to break because my network is not ready yet to handle another system, and then I have to stop and come back to this system and then keep on building more and more. Efficiency comes into play when it's done pretty early. So final points, I'm not going to take a lot of time. What problems do we solve? We make the infrastructure of today, which is hybrid or physical or whatever you want to say, ready to be efficient, to be cost-effective, and to be scalable and flexible throughout physical and virtual and whatever. So that's our main goal. And to keep it simple. I don't have a dashboard here that I can show you. I don't have the time. But the idea here is to keep it simple. You have a lot of dashboards in your environment. You have a lot of alerts coming up in your environment. You have a lot of charts going through your environment. That is not the goal here. The goal here is to make it efficient, to make it simple, to make it time efficient also in that place. And that's the whole idea of having this visibility layer in place. Okay? That's all from me. Any questions? Feel free to ask anything about this. I'm ready, so I have about 5 minutes more. And if there are questions, please let me know. If not, we can talk outside or we can talk through emails or whatever. So, any questions? All right, thank you very much.